Hello, let's talk about gases. So in this video, it's probably going to take a couple of videos to get to where we need to be. But in this first one, we are going to review partial pressure, Dalton's law of partial pressure. You can find these on page 434. We're also going to convert a pressure unit just so you see if you are given pressure in a unit that is not ATMs or kilopascals, which is what we will use most commonly, how to easily convert that. And then these are the practice problem page numbers, and so we will access those pages as we go along. So the first question that we're going to take a look at is the Dalton's law of partial pressure. This is number 45 in chapter 12. And the question says, I'm expecting you to turn there and read with me, so I'm not going to read so slowly that you could write everything down. But the problem says, what's the partial pressure of water vapor in an air sample when the total pressure is 1 atm? The partial pressure of nitrogen is 0.79 atm. The partial pressure of oxygen is 0.2 atm. And the partial pressure of all other gases is 0.0044 atm. So this is number 45 on this page. So if you recall, we said that the partial pressure, so Dalton's law says that the total pressure is equal to all of the pressures inside a container up to, infinity pressures, numbers of pressures that we have. So it tells us here that our total pressure is 1.00 atm. And then we've got this list of gases. So the nitrogen is 0.79 atm. And the next one listed is 0.20 atm. And then we have this one that says a bunch of the other gases in there. This is a mixture, is 0.44 atm. All right, and then we have our oxygen, and I've run out of room, plus the pressure of the O2. Is it O2 or water vapor? Sorry, it's water vapor. Let's fix that. The pressure of the H2O. Okay, so this becomes fairly clear for us to do. This pressure, this is just addition and subtraction, like this is an unknown, so this is a basic algebra problem. We're going to add these up and subtract it from 1, and so we are going to get that the partial pressure of the H2O is 0.10 atm. All right, so you should give that a run and see if you can come up with that response. All right, the next one we're going to look at is question number 48, because it actually asks us to make a couple of different conversions, and you can reference the table. The information that we're going to be looking at here is from the pressure table on page, pardon me, while I pop back over there for us. This is the pressure table on page 407. So there's a table on page 407 where you can get these equivalencies. So let's take a look at this question. It says the atmospheric pressure in Denver, Colorado is usually 84.0 kPAs. What is this pressure? So what is this same pressure in ATMs, and what is this pressure in torr? All right, so we have two conversions to do here. All right, so what we would simply do is look at that table and say, what is equivalent pressure? So just like stoichiometry problems, we'll start with what we've been given. Let's say, well, if I'm going to ATM, the chart tells me that 1 ATM is equal to 101.3 kPAs. So 84 divided by 101.3, that would give me 0.332 ATM. All right, now let's make the conversion to torr. 84.0 kPAs. Now let's look at, if we look back at this now, we'd say, okay, so what is our conversion to torr? Well, anything in that first column is equivalent to each other. So this means that 101.3 kPAs is the same as 760 torr. So now we will take 84 times 760 divided by 101.3 kPAs, and this will be, if we round it for sig figs, we should get 6.03 times 10 to the 2 torr. Now I might say, well, why, Ms. Frazier, did you put it in this format instead of just listing 630? Because those are the same number. This number does not have the correct number of sig figs. 6.30 has 3 sig figs like our beginning data, so we would need to record our answer as 6.30 times 10 to the second torr for proper sig figs. All right, so that really is all we need to, that's all the math that we need to take away from chapter 12. The other thing that we'll be talking about there is the kinetic molecular theory. So here is one thing that I would like for you to do. Would you please, so you are going to answer number 46 on page, was that same page number? Answer number 46 on page 434. 46 on page 434 will be your assignment from chapter 12. Okay?